One of the first projects I worked on when starting machine learning was the following. I was working in aviation insurance, and I was trying to categorize accidents according to what caused the accident. Was it the pilot error? Was it a problem with the aeroplane? Some kind of mechanical problem with the aeroplane? Or was it some external factor, such as the weather, or, for example, another aeroplane? What I did have was a long description from the NTSB in America of each accident, and it would say something like, the pilot was flying along calmly, minding his own business, when all of a sudden a flock of geese flew by and one of them was ingested by the engine, and this caused an accident, or something like that. And the idea was to try and use the words in the description to categorize whether this particular accident was due to pilot error or not. I did have a load of historic information where that categorization had already been done by experts in aviation safety. Let's look at some of the words that I had in the description. By the way, this kind of analysis should be familiar to anybody doing the NLP course, but even if you're not doing any kind of course like that, hopefully you can follow along. Some of the words we might have: pilot, failure, control, loss. Now imagine you are given a description of an accident and you're allowed to choose one word with which to take the decision, was it due to pilot error or not? Which one would you choose? You can't, for example, choose two together, where you might choose loss of control or something like that. Most people I've asked said they would choose pilot. They would take the decision based on whether the word pilot was in the description or not. If pilot is in the description, then they would say it's more likely to be discussing something about pilot error, because whenever you're talking about pilot error, the word pilot is going to be in the description. Whereas if the word pilot is not in the description, it might not be to do with pilot error. It feels quite unlikely to be to do with pilot error. It might be, for example, there was a lightning storm. How can we express this simple decision of ours to decide whether it's based on pilot? Well, imagine you have your overall data at the top, and 75% of accidents are due to pilot error, and the first thing you do, the first decision you're going to make, is going to be based on pilot. If pilot is in or not in the description. If pilot is in the description, you're going to say that it's due to pilot error, and if pilot is not in the description, you'll say that it's not due to pilot error. That is your first decision tree, and actually doing this recording was a nice change, maybe, to trying to do this in the lecture hall. Typically, when I'd ask the 100 or so people sitting in the lecture, which word would you choose out of pilot, failure, control, or loss, there was a collective blank, like, this is a really hard question, or maybe it's a trick question. So this time, there's a collective silence, but at least I'm expecting it. And here we have the diagram a little bit more neatly. Let's talk about some of the contents of this diagram. At the top, we have some information about the data before it's split. So the 100% means we're talking about 100% of the data. N equals 9,826 is the number of examples which had been categorized by the experts. And the 0.74 over there means that 74% of all accidents are due to pilot error. We make our decision based on pilot. On this side, pilot is in the description. On this side, pilot is not in the description. The package I used labels these things in a slightly confusing way. I've used R for this because the diagrams come out quite neatly, but the word pilot is represented by a 0 or 1. And over here we have pilot less than 0.5. So if pilot is less than 0.5, pilot is 0, and that means it's not in the description. If pilot is greater than 1, if pilot is greater than 0.5, it's 1, and it means pilot is in the description. Anyway, after we have made this decision, if pilot is in the description, the data tells us that there's a 97% chance that that is due to pilot error. On the other hand, if pilot is not in the description, there is still a 50% chance that it's due to pilot error, which, to my mind, is actually pretty remarkable. But anyway, you've done it. That is your first decision tree. Thinking a bit more, if you now had to come down here, for example, no, let's say come down here where pilot is not in the description, and you had to choose out of the words failure, control, or loss to decide within those which accidents are due to pilot error and which are not, what would you split on next? So after you've chosen all the descriptions that don't have the word pilot in, you're trying to be a bit more accurate in there. Can you split those 47% into pilot error and not pilot error? You've done the splitting once. You're now going to split again. So this is essentially a recursive procedure because you're going to do it again and again and again. Every time you do this procedure, you are partitioning the data. So we're doing recursive partitioning. Maybe it's unsurprising that the package in R which does this is called rpart. Anyway, what would you choose? Failure, control, or loss? Let's have a look. Well, what would I choose? I kind of feel like loss of control might be a good indicator that the pilot lost control, although it still puzzles me why the word pilot wouldn't be in a description, which was due to pilot error. Well, here's a slightly bigger decision tree. Where did we go? Interesting. The next word that actually got used was failure. If the word failure is in there, we're back up to 75% due to pilot error. Offhand, I can't imagine what the sentence would look like, which doesn't have the word pilot in, and it does have the word failure in. And you can see R has recursively partitioned again and again, and it ended up with information down at the bottom. This is a slightly more complicated decision tree because in order to categorize data, hey, can you hear the ice cream van? I've got to say, it's very tempting. It's boiling hot out there, something like 26 degrees, which for the UK is far too hot. I come from the north of England, where we were lucky if it ever got up to 17 degrees, which is fine by me because I like it cold and rainy and dark, so summer is not my best time. Sorry, I'm getting distracted. Where were we? Ah yes, decisions. If this was your decision tree and you needed to make a decision about whether to classify an accident as pilot error or not, you potentially have to get 4 pieces of information and partition your data into 1, 2, 3, 4, 5, 6 bits. Every piece of data will end up in one of these 6 boxes. They are called leaves. If, for example, the word pilot is not in there, the word failure is not in, the word control is not in, and the word loss is in, so it could say something like loss of pressure, then there is a 30% probability that is due to pilot error.